I have here one of the Lenovo power supplies for the all-in-one machines that they have, like M90zs, M70s. So this one, obviously, it was on the scrap bin. Something must be wrong with it. So we're just going to plug it in. This is a passive power supply, so there's no fans in it. There's no way to know if it's on or not. The only thing we're going to have to do is to test the voltages and see what we got. We should be able to get, this one is kind of easy. Here we have the green cable. We can short that out later, see if there's any change. But we're going to test the voltages from the black terminals to the yellow ones and see what we got. Again, I don't like to blow up multimeters, so I set it up on the higher end, DC voltage, 200 volts. As you can see, we have the black leads only on this side, so we're going to go for one. And now we're going to start testing the voltages on each of these. We should have at least 5 volts on each. There's nothing on this rail, nothing here, nothing here, nothing, nothing, nothing here, and 5 volts on standby. So it seems only one of the rails is working. Most likely it's another capacitor, as we saw earlier. These ones are very small, so I cannot put one of these big clips, so I'm gonna use one of these to short it out. And now that we have those two pins shorted, we're gonna go over the voltages again and see if there's any change. Nothing. Got nothing here. Nothing. Seems only one of the 5 volt rails is working. Yeah, so only one of the rails is working. Most likely it's another one of those capacitors or the winding on the transformer. So we'll open it up later and see what we see. So I just unscrewed this sucker, and we're gonna open it up. I had to take out the I forgot what I put in. One of those zip ties that hold the cable, so we can take out the case. So now that we have the cable out, we can look at the insides of it. I don't see anything major. None of these seems to be blown. None of the capacitors seem to be blown or swollen. We have a solid state capacitor here. Some of the regular ones. The board is kind of flimsy. And we have the primary transformer. And nothing seems out of place, so we're going to have to do some probing. I don't really like these compact power supplies. I really don't like them at all. Of course, they have the components, so almost touching to each other. We have ceramic caps, they're touching the other leads. That's it's no good. It is no good. You can see they already put adhesive to keep things from touching each other and from moving. So this obviously was refurbished at some point. So we'll do some probing later and see what we can find. Remember, we were testing those 12 volt rails, the yellow cables with the 12 volts and the blue cable here with the 5 volts. Actually, when you trace it back to the board, you can see that they're actually numbered. So we have the ground, all the blacks to 1 is not individuals. We have the 12 volt rail for the on the yellow cables and the 5 volts. So obviously something's wrong with the 12 volt rail, and later on I'm going to take out the board and try to trace it, see where it goes. Guys, so I mean, you kind of missed half of the fun, but we started before measuring the voltages on this. We had a 5 volt standby and the 5 volt power on it, but we were missing the 12 volts. So I did a little probing and it turned out to be something very simple. But just to review, when we take it out, the first thing you have to do when you do this thing is try to discharge these capacitors. I will show you later how, one of the cheapest ways to discharge those capacitors, which is by shorting the two leads, and it gives quite a spark, which kind of tells you that if you inadvertently touch any of this part of the power supply, you're gonna get a nice shot, and you don't want that. You really don't. So basically what it turned out to be, I was doing a little probing and testing the caps here as well as the capacitors, which all show good. There's some diodes down there. Everything was testing fine so far. There's another diode in there, Schottky diodes, checking the all these relays and the transformers, all that stuff. Everything was checking out fine. But then, as I was tracing back the 12 volt rail in here, this would be the ground. I don't want to touch anything, but this was the ground. This is the 12 volts, and this is the 5 volt power on and standby. The standby, the 5 volt power on is back here. But as I was tracing it back, I noticed that in one of these power FETs that we have here, one of the MOSFETs here, there was a cold solder joint right here. I will show you what it looked like. So we had a cold solder joint on this one, and what I did was, everything else checked out fine, and that solder joint was kind of suspicious. So what I did is I resoldered it. So I will show you on that one. And what do we get after that? So this is one of the MOSFETs, power transformers, and this is the joint that looked kind of suspicious. It looked like a cold solder joint. So I resoldered that one, and as you will see as we plug it back in, we got power on everything. So that was a very nice and easy fix. Always examine the board when you look at it. Give it a look thoroughly, check for cold solder joints, anything that looks suspicious, that it doesn't look like a good solder quality, redo it. Obviously, check the caps and the diodes. You can check the windings if you know how to do so, but first check, as always, give a quick look at the board, look at the joints, see if anything checks okay, do some continuity checks from some of the certain points of the from the high voltage where it converts to the DC. You can see some of the high voltage cutouts in here, so the power doesn't go crossover. So let's plug it in, and I'll show you the readings that we got. I also just want to say that if you're testing a live component like this, it is very good, a very good idea to not just plug it out to the mains, but have this cable go through like power something, isolation transformer. This doesn't create a common ground, so it will help you out in case you get shocked. You will not get grounded, so those things will save your life. So now, as we plug it in, we got a trusty multi here. This is one of the ones that I spoke about before. Let's see. We can see here. So we get the black on the ground, and now we can start testing. We got the 5 voltage on the standby, 5 voltage on the power on, and we got nothing on the 12 volt rail. So what do is like we mentioned before, you use kind of like a paper clip, or I use one of these because it's rubberized, so I don't want to get shocked in the middle of doing anything. So we short the green and the black anywhere, it doesn't matter, one of them. And now as we take one of the black ones, you will see that we get 12 volts on that rail. So this power supply is fixed. Again, if I take it out, if I cross it and I put it back again, we got nothing. It's just whatever power that was built into that capacitor that is discharging right now, and that's the big capacitor. Right now, let me take this out. I'm just going to show you really quick. This capacitor is fully charged right now. So even if I unplug it, and this happens every time you especially work on an iMac, the power board is like this, and you remove the LCD and you kind of brushing through it. Let me see. This is, and that's what you get. Imagine if that happened to your hand when you touched it. You would not like that at all. So anyways, this board is fixed. I'll put it back together, and that's it. Always remember, look at the board, anything suspicious, resolder it, check really the components. Most of them you have to take them out, but that's one good power supply we got right now.